Hello, and today we're going to cover operator overloading in C++. I'm going to start with modifying the point3d class that I have been modifying in previous videos that I created. And I'm going to overload the plus, minus, asterisk for multiplication and the / for division. I'm going to overload those operators so that way point3d can use those operators and we can add, subtract, multiply, and divide one point3d with another point3d. But before I actually get started with that, I want to delete these print statements for the constructors. We've been seeing them. I think we've seen them enough, and I don't really want to see them anymore. So we have our constructors, destructors, we have some methods, setters, and getters for the class. And now if I want to go about overloading an operator, well, there's many operators that you can overload, but here I'm just covering 4, right? And how can I go about that? Well, I'm going to start by returning a point3d. I'm going to say operator as a keyword, and I'm going to say plus. The input, I'm going to say const point3d. It's going to be p. So here's how I go about declaring it. What's the kind of format that I use for overloading these operators? Well, operators are usually a case-by-case basis. You won't usually want to think quite hard or as hard as you can about what's going to happen when you add 2 points together, right? For me, I have to think about what's going to happen when I add 2 point3ds together. What am I going to add? For me, that's simple. The operator, how I'm looking at it is, I want something like this. I have the left-hand side plus the right-hand side. And that's going to be stored somewhere. Right, I'm going to say x equals the left-hand side plus the right-hand side. So the left-hand side is the class declaration here. The left-hand side is all this. Left-hand side has access to _x, _1, _z as they are. And p is going to be the right-hand side right here. So this is going to be p, and this is going to be this whole entire class declaration here. So if I'm adding these two quantities together, well, shoot, I don't want to overwrite the values inside of LHS, the left-hand side, that's this body code. I want to use the values here and take p right here and add it to my values as a copy, and then that result, I want to have it thrown into x, right? So what I'm trying to say here is that I shouldn't do something like this. I don't want to do this because here I'm going to be modifying the left-hand side. But when I'm doing this arithmetic operation, well, let's take integers for an example, right? If I say z equals, 3 plus 6, right? This doesn't change to 9. It's z that gets changed to 9, not this. So I should treat it that way. So I shouldn't use something like this. I should use something like this. And why do I want to use something like this? Well, here I create a temp, which is going to kind of serve as our x here. This is kind of, temp is going to play the role of x. You know, the x, y, and z that's here, this comes from the left-hand side, and then p, of course, is the right-hand side. So I have temp and I have set x, and I call my getters, and I call temp setter, and I use the getters, I add them together, and that result is the input for my setter for temp. So I set x, set y, set z, and I use the x, y, and z getters from both the left-hand side and the right-hand side, add them together, and that's going to be temp. Another way of looking at this is like this. This is another way of looking at that. I'm doing temp.x, right, with set x, and I use the class's x, the class that calls this operator, which is the left-hand side, and I use the inputs x, add them together, and that's my temp x. So that lets us have this behavior. And because I want the data inside here to be modified, meaning the class that calls this, I set it equal to temp, and I return that. So this lets me add the private data on the left-hand side of this operator while taking the right-hand side, which is the argument p here, adding the x, y, z values from here with the class that calls this, storing it into a temporary local variable, and having a copy of that returned. And again, I want to do this because I don't want to edit the internal data inside of this class, because I want to kind of mimic the behavior of adding like integers, for example. the 3 doesn't change. I just read the values from there, read the value from here, and I use it to get the result. So that's what I'm doing here. I read the value from the left hand side, then I read the value from the right hand side, and I use that to create a temporary variable and return that. So that way the data inside of both sides of the plus are unchanged. Now let's see what it would look like for the minus and the multiplication operators. So these are, well, quite simple. Right now that I want to edit the minus operator, I have .3d operator, then the minus symbol, and I have my input. And similarly to how I add two .3ds together, I'm using essentially the same syntax for minus. The only difference between minus and plus is that I change the plus symbol with the minus symbol. And I do the same thing with multiplication. Actually, let's put a new line here. There we go. Right, so here, I mean, this doing work for this isn't so bad. I just want to add, subtract, and multiply element by element. Right, you can consider this doing like an element-wise multiplication. So I take each element of one end and multiply it with each element of another variable. However, things are going to get a little bit more complicated when it comes to doing the division. Overloading the division operator is just a little bit more complicated due to the fact that we can't divide by 0. So how do I go about it? Well, my intention here with this overloaded operator is to do a division element-wise. Maybe there might be another way of doing the division due to the math, but for this example, I just want to do an element-wise division. So I'm going to be dividing the left-hand side of the division operator's x, y, and z values with the coordinating x, y, z values of the variable that's on the right-hand side of the operator, the division operator. But now I have this check here where I need to check if any of the elements of p are equal to 0. Well, what I'm going to do is I'm going to throw an error. And this is something I don't want to cover in the scope of this video just because it'll open a can of worms. But what I'm doing here is that I'm going to throw an error. And in order for me to use std overflow error, I need to include the std except header file. So by including this, I'm able to use the std overflow error. Now that I'm having these 4 operators with their arithmetic operators overloaded, let's see how we can go about using these operators. And well, since I only overloaded these 4 operators, I need to have constructors for these next variables. Unfortunately, at least not yet, I can't do something like this. I only have half of these operators overloaded. So if I try to do something like this, since I haven't defined any behavior for the equals operator, the compiler is going to freak out and say, hey, what the heck? So for right now, I'm just going to limit myself to creating new classes and printing them out. And here's how I'd go about testing my code. First thing first, but since the constructor for Q initializes everything to 0, I'm going to be setting every parameter, every attribute inside of Q here to 1. Just so I know that when I do these operations, I can see the difference. So here I create a .3d class A, which is the sum of T and Q. Then I create B, which is the difference between T and Q. And then, well, if I multiply by 1 and divide by 1, I'm not going to get any interesting results. So C is going to be the product of E and T, which is going to be these values squared. And then D is going to be the quotient between T and E, and that should be 1, just because I'm dividing these numbers with themselves. Then I call on A, B, C, D to print these values. So why don't we see the result? And here we have it. 1 plus 8.3 results in 9.3, and then 1 plus 7.6, 8.6, 1.2 plus 1 is 2.2. So it looks like our addition operator is working correctly. Now we do the subtraction. If we subtract this by 1 on each element, we get 7.3, 6.6, and 0.2, which is correct. Finally, here we go about squaring each element inside of the point class, which results in the correct answer. Finally, when I divide a number by itself, element-wise, I get a result of 1. So by the looks of it here, all my operators are functioning correctly. But I have a problem. For the sake of convenience, it's kind of annoying that I have to do something like that. I'd rather do something like this, where I can say point 3D A equals T plus Q, and so over for these values, these variables here. So in order for me to do this, I need to overload the equals operator, which we'll do in the next video.